Hello everybody, Math with Josh here. I'm Josh. There's a video that's gone a bit viral on Twitter that I felt the need to get a response out to quickly, so I'm a bit sorry for the video quality. The video is just showing that the Common Core way to do this, allegedly, do multiplication is horrible, but the old way is great. Now, I am actually not a fan of a lot of the particulars of the Common Core stuff, but this video needed a response. So what it shows is that, this method on the left is a fairly efficient way of doing multiplication, which is true. And it shows a teacher demonstrating this sort of figure on the right and making fun of how long it takes. Well, first off, this is stupid because how quickly you can do something is vastly different from how long it takes you when demonstrating it to a class of students for the sake of them learning. Right? Like, I can do simple calculus problems really quickly. If I were explaining calculus to somebody, that would not be my goal with every step. But second off, these are two different ways to do multiplication problems. And I think what's missed in a lot of the knee-jerk criticism of this is this method on the left, which, depending on your age or where you grew up, you might have been taught slightly differently than me how to do the carrying. That's not important for this. This left method is a very efficient algorithm for doing multiplication. It's how I do multiplication. It's when I math tutor students, I teach them this algorithm to do it. Right? I think it works very well. But the big thing is, this method on the right, and I want to keep this video nice and concise, shows in part, and especially if it's explained properly, why multiplication methods work. So I'm going to have to erase the board in a second here. Because here's the thing, this method on the left always pops out the right answer to a multiplication problem. But why? Now, if you're watching this, if you can't explain why this method on the left works in general, that's okay. Right? You were taught it once, maybe 15, 20, 40 years ago. And that's fine. But if you don't remember, what you're missing is that there's actually something kind of magical about this, which is worth understanding and hoping to explain to kids properly if we want them to be able to do something other than act like a calculator. So let's look at this one more time. Erase the board. This is a very high-tech eraser. It's entirely organic, right? So we had this problem, 35 times 12. Now that means, we'll just for the sake of this, that's, I bought 35, I don't know what a funny object for this is. I bought 35 cases of pop, and whatever. Right, I bought 35 of something that cost $12. So, what we would actually do is we would add up 12 plus 12 plus 12, right? I'm going to say 10 of those here. Right. So, 3 rows of 10 12s. And then 5 more here on the bottom. Sorry for the very shoddy camera work. I'm learning, everybody. Right, so 35 times 12, we'll say this is 10 12s, 10 12s, 10 12s, 5 more 12s. That's 35 12s. So we could add those up. We go, okay, 12 plus 12, that's 24, plus 12 is 36, plus 12 is 48. And we would go a little bit insane. We might realize that these first 3 columns, being 10 times 12, are 120 each. And this bottom being 5 times 12 is 60. And that 3 times 120 is 360, plus 60 is 420. You might notice that. But there's a lot of theoretical writing here breaking this into pieces. So you probably know, and the reason you were taught this is so you'd be better at multiplication, better able to actually do it by hand. You were taught the classic approach, 35 times 12. 2 times 5 is 10. 2 times 3 is 6. Add the 1 that we had carried. That's 7. Put a 0 down here. 1 times 5 is 5. 1 times 3 is 3. And we add. We get 0. 2 carry the 1. 4. That method is very efficient. But why did it pop out the right answer? And I don't mean to sound mean about it, but if you don't know why this method works, then you're missing why a lecture on mathematics might show a slower method for the sake of letting students see why this efficient method spits out the right answers instead of random numbers. So thank you very much for watching, everybody. Once again, this is Joshua Phillips, and have a nice day.